Video, I'll show you how to calculate regular payments or deposits using the annuity formula. This is question number 1. The question asks, George wants to retire in 30 years with 1 million in RRSPs. His current investments are earning on average 12% per year compounded monthly. What regular monthly deposits must be made to have the required amount at retirement? To answer this question, we'll need to use this formula. And the letters in this formula are defined below, where A represents the future value amount, and in our case it's 1 million. R represents the regular deposits or payments, which is what we're looking for. I is the interest rate per compounding period, and N is the total number of deposits. Now we are told that he wants to have $1 million at the end of the 30 years. So his A value will equal to 1 million. Furthermore, we are told that he is earning 12% per year compounded monthly in interest. So his I value is equal to 12%, but notice that it's 12% per year. Now since it's being compounded monthly, we have to take our 12% and divide it by 12, which represents each month of the year. And if we do that, we end up with 1%. Now we don't work with percentages when we solve these problems. We work with the percentage version of the number. So in our case, we would have to divide this by 100, and 1% represents 0.01 in decimals. To find out our N value, remember that he is going to be depositing money every month for the next 30 years. So our N value is going to be 30 times 12, which is equal to 360. Now all we have to do is substitute all of these values into this formula right here. So let's go ahead and do that. 1 million is equal to the R value that we're looking for times 1 plus 0.01 to the power of 360 minus 1 over 0.01. And to solve for R, we have to get rid of the 0.01 that is located in the denominator position. So I'm going to multiply both sides by 0.01, and that will eliminate that. And on the left side, we have 0.01 multiplied to a million. You can evaluate the left side now. I'm just going to leave it the way it is. Now what we're left with is this expression on the right side. We need to find out what R is. Now to get rid of everything else but R, we have to divide both sides by this. And if we do that, I'm just going to erase what we have here. We end up with 1 plus 0.01 to the power of 360 minus 1. And this cancels out. And we're going to have the same thing on this side. Now, if we evaluate the left side, we will have our R value. Keep in mind that if you do not know how to do it manually, you can always remember this formula, which automatically gets you the R value once you plug in those values. So let's use our calculator. 0.01 times 1 million divided by this expression, 1 plus 0.01 to the power of 360 minus 1 gives us 286.12. R is equal to 286.12. So what does this tell us? This tells us that in order for George to have $1 million in RRSPs by 30 years, he has to put in a value of $286 and some change every month for the next 30 years. Now that's pretty good because 12% interest is quite high. And if you can get 12% per year compounded monthly, then I would do the same thing. So there you have it. That is how to calculate regular payments or deposits using the annuity formula. Stay tuned for question 2. If you found this tutorial helpful, please support our channel by subscribing or by liking this video.